sent this paper over continual learning of large language models. Wow, this is a lot.
Yeah, it's a really interesting area. It gets at how these LLMs, which we hear so much about, can actually keep learning and adapting over time.
Which is, I mean, it's a huge deal, right? Because, like, you train one of these massive models and then boom, tomorrow, new information comes out. It's outdated.
Exactly. And that's the challenge, right? We can't just retrain these giant models from scratch every time something new happens. So this whole idea of continual learning is essential.
Okay, so let's unpack that a little bit. The paper divides this idea of continual learning into two main types, vertical and horizontal. What's the difference?
So think of vertical learning kind of like building a skyscraper, right?
Yeah.
You start with this broad base of general information, almost like a massive encyclopedia. Then, as you go higher, each layer gets more and more specialized. You might train it on data from a specific field, like medicine or law or something.
So, like, a company could take a general LLM and then further train it on their own internal data. They'd have this specialized model just for their needs.
Exactly. And that's super powerful. But here's the catch. As you build higher and higher, there's this risk of the model forgetting that foundational knowledge from the lower levels.
Oh, so it's like they might become super specialized but then forget basic common sense.
Exactly. And that's a huge challenge that researchers are trying to address with vertical learning.
Fascinating. Okay, so that's vertical. What about keeping these LLMs up to date? Like in a world that's constantly changing. That's where the whole horizontal thing comes in, right?
Right. Horizontal continual learning is all about adapting to that constant flow of new information. New tweets, new scientific papers, new events, you name it. And it's got to do this without just like dumping everything it knew before.
So it's like LLMs need to know that, for example, Messi doesn't play for Barcelona anymore, or that, the latest update to some software has new features.
Perfect examples. It's all about staying relevant, keeping up with the times.
Which, okay, that brings us to maybe the most important question. Why should someone who's not an AI researcher care about any of this? What's the so what factor?
Yeah. Well, whether we realize it or not, LLMs are already powering so much of our digital lives. They're behind those chatbots that pop up on websites. They're influencing the recommendations we see on streaming services, all sorts of things.
And how well those LLMs work, how accurate and how helpful they are, really comes down to how well they can learn and adapt, right?
Absolutely. That's why this whole area of continual learning is so important. It's the key to making sure these models don't become obsolete or even worse, start giving us biased or outdated information.
So it's not just some abstract technical thing. It's about making sure these AI models are actually useful and trustworthy tools that we can rely on more and more. So we've talked about what continual learning is, but how do these LLMs actually do it? Like, how do they learn in a way that you can just keep adding on and updating?
Well, the paper breaks it down into like three main stages, almost like a curriculum or something.
Ooh, I like that. The LLM curriculum. Okay, lay it on me.
So the first stage is continual pre-training, or
Hmm.
CPT. And this is like the foundation, right? It's where the LLM gets exposed to just mountains of data, tons of text, code, whatever, to build up that basic understanding of like how language works, how the world works.
So back to our skyscraper analogy. This is laying the groundwork, pouring the concrete for that huge tower.
Exactly. But get this, there was this one study, right?
Yeah.
They found that even after like just a few months, an LLM's knowledge base could already be, kind of outdated.
Really? I mean, how much can change in a few months?
You'd be surprised. News cycles are moving faster than ever. New scientific discoveries are popping up constantly. Stuff on social media can be here today, gone tomorrow. LLMs got to keep up with all that.
Yeah, okay, that makes sense. So how does this CPT, this first stage, how does it actually handle all that new info coming in all the time?
So one really cool approach is by creating these like specialized experts within the LLM itself.
Hmm.
Instead of having this one giant brain trying to learn every single thing, it's more like a team of experts, each one focusing on a specific area.
So you could have like an expert on current events, an expert on pop culture, an expert on, I don't know, like the latest advancements in rocketry, and they all kind of work together within that same LLM.
Precisely. And this helps a lot with that whole forgetting problem we talked about, because each expert can focus on updating their own little area without messing with what the other experts know.
That is so clever. Okay, so CPT, that's the foundation, helps keep things up to date. What about the next stage in our little LLM school here?
Next up is domain adaptive pre-training, or DAP. If you think of CPT as laying the foundation, DAP is like actually building the house on top of it, but customizing it for who's going to be living there.
I like that, making it a home, not just a building.
Yeah. So let's say you've got an LLM that's been trained on just tons of text, code, all sorts of general stuff. With DAP, you might then train it on, I don't know, a data set of legal documents, right? Now you've got an LLM that's geared towards legal tasks.
Like our friend who used an LLM to go through all those contracts, that was DAP.
Exactly. But, and this is important, just like with the vertical learning, we got to make sure this legal LLM doesn't suddenly forget everything else it knew, right? It still needs that foundation.
Oh, for sure. That would be a disaster. So what do they do during this DAP stage to stop that from happening?
There are a bunch of techniques, but one that's really cool is called LaRA. It's a way of fine-tuning the LLM on that specific data, like those legal documents, but without messing up the core knowledge, like giving the model a set of specialized tools for that job, but not overriding its entire skill set.
So it's like our lawyer LLM, it's got this fancy briefcase full of legal terms and precedents and stuff, but it still remembers how to have a normal conversation, how to like understand basic English.
Exactly, that's the key. We want these models to be versatile, right? Adaptable,
Yeah.
even as they get more specialized.
Okay, got it. Foundation with CPT, specialization with DAP. Hit me with the final stage of LLM education.
Last but definitely not least, we have continual fine-tuning, or CFT for short. If DAP is building the house, CFT is all about furnishing it, decorating it, really making it feel like a home.
All right, I'm intrigued. So CFT, this is where the LLM gets to actually use all that knowledge it's built up, right? Like actually doing stuff, not just learning.
Exactly. It's where things get really practical. And the paper talks about this really cool area of research. How to use CFT to continually teach LLMs to be better at following instructions. It's called Continual Instruction Tuning, or CIT.
So instead of me having to like pull the information out of the LLM, it could actually just DO things based on what I ask it to do.
Exactly. Think of it this way. It's like, instead of just having a bunch of cookbooks on your shelf, you've got a sous chef who can actually make the dish based on what you're in the mood for.
Okay, now that is what I'm talking about. We've gone from giant knowledge sponges to specialized experts and now to LLMs that are like taking orders and making things happen.
Yep.
What's next? Are we going to have like sentient LLMs by next week or something?
Let's maybe pump the brakes a little on that. But the paper does mention some pretty wild stuff that's emerging from all this research on continually learning LLMs. One thing that really jumped out at me was this idea of anticipatory recovering.
Anticipatory recovering. That sounds like something out of a movie, you know?
It kind of does, right? It's like, imagine the LLM actually develops a memory of sorts. Researchers found that after training on these long sequences of information, the LLMs were able to relearn earlier parts of that sequence way faster the second time around, even if it had been a while since they'd seen it.
Hold on, wait. You're saying it's like the LLM remembers something it learned before, even if no one specifically told it to remember it?
That's the idea. It's like it's forming these, I don't know, deeper connections between different pieces of information.
Yeah.
And that lets it recall stuff way more efficiently. Now, this is still early stage research, but it's super exciting. It suggests that these models might be capable even more than we thought.
That's kind of wild, honestly. A little spooky, but mostly wild.
Okay, so anticipatory recovering, that's one thing on the horizon. What else are researchers trying to figure out in this world of continual LLM learning?
Well, one of the big ones is efficiency. I mean, training these things takes a massive amount of data and computing power. Imagine if every time there was a new scientific breakthrough or like a huge news story, we had to retrain all these models from scratch. Not exactly practical.
Yeah, no kidding. So finding ways to make this whole continual learning process more efficient, that's got to be huge if we actually want these models to be like useful and accessible to everyone.
Totally. And then there's this whole other area of research that's focused on transparency and control, because right now, a lot of what goes on inside these LLMs, it's kind of like a black box. We don't always know why they make the decisions they do. Yeah, it's like we can tell they're smart, but how they got so smart is a bit of a mystery. And, you know, sometimes that can be a little unnerving.
For sure. So there's a lot of really important work being done to make these models more transparent, give us more control over how they're learning and how they make decisions. And then, of course, is the question of personalization.
Ah, yes, my personalized LLM best friend who knows everything about me and helps me with everything. I can't wait.
Right. Imagine an LLM that adapts to your learning style, to your interests, heck, even to your sense of humor. There's so much potential there.
Mind-blowing, honestly. Okay, so we've got efficiency,
Yeah.
transparency, personalization. It seems like there's just so much happening in this field of continual learning. If you had to leave our listeners, who are all, you know, incredibly smart and interested in this stuff, with one big takeaway, what would it be?
I think the biggest takeaway is this. We are just at the very beginning. What we're talking about here, this is the start of a whole new era of AI, one where these models aren't just these static tools, but they're constantly evolving. They're like partners, helping us make sense of this increasingly complex world of information.
So the next time you're chatting with a chatbot or using, I don't know, a language learning app, remember behind all that, there's this whole world of continual learning happening. It's making those interactions smoother, more relevant, more, well, more human.
Couldn't have said it better myself.
Mhm.
This is a field that's moving at lightning speed. Definitely worth keeping an eye on.
Absolutely. Well, this deep dive has given me a lot to think about. Really appreciate you taking the time to, to break it all down for us.
My pleasure. Anytime.